for the benefit of those who are not able to attend. And then let me share my screen. So today is Wednesday, January the 25th. Let me remind you that if you have not taken the Module 1 exam, it is now open and it will close on Friday, January the 27th of 2023 at 11:59 p.m. You do have to take it in one sitting. I would tell you to allot about an hour and a half. I do not think it'll take you that long, but again, because you need to make sure you allot enough time, I would tell you to allot about an hour and a half. There is no monitoring, so you don't have to use any kind of special system. Excuse me, you may use your notes, PowerPoints, etc. from the lessons and resources that are in D2L. I mentioned on Monday, and I mentioned it here again, we are omitting class participation number 4. It deals specifically with qualitative data, which was at the end of Module 1. We just don't have time, so I've omitted class participation 4. From the we're going to pick up with the lesson we were in on Monday, which was dealing with specifically quantitative data and looking at how to organize it and so forth. But I want to kind of get us back into it, and then we're going to take a look at Minitab. So I'm going to kind of toggle between what we did the other day, which I have copied here onto this document, and some information on the PowerPoints. So we began talking about specifically quantitative data. And I mentioned to you at that particular point that research, we went through the steps, that research typically begins with a question. There's something that we want to know about. And so we pose a question. The question that I posed for us on Monday was, what is or what was the average age of a GHC student in fall 2021? And I mentioned to you, you want to state your question as clearly and with as much detail as possible, because that helps you to then do step 2, where you need to identify the variable, the population, the parameter, the sample, and the statistic. So we pose our question, but then, and our goal ultimately is to be able to answer that research question. And so then we had to talk about ways to organize the data in some meaningful way. And we began talking about a grouped frequency distribution, which I'm going to kind of review in just a minute. But then we also talked about how we could also organize the data in such a way that your audience, whoever you're doing the research for, whether it's for yourself, for your employer, for a research facility, and especially if you're going to make some sort of presentation, you need to be able to display your data, your information in a very easy, understandable way. So we often use graphs to do that. And so that's kind of where we was thinking about how to do that organization. So from our question, we indicated that our variable was the age in years, which is a quantitative discrete variable, because if I were to say to you, Alexis, how old are you? You would likely respond with a number, with a whole number. For example, I would tell you I am 54 years old. So we tend to state our age in years as a whole number. That's why it's discrete, but it's also at the ratio level. Based on the way the question was worded, we determined that the population was all GHC students enrolled in fall 2021. Again, you want to be as descriptive as possible. Okay, you want to be as descriptive as possible, including kind of the who, the where, when, that sort of thing. The measurement that we ultimately want is the average age in years of all, GHC students enrolled in fall 2021. And I pointed out to you, and I emphasized it because I wrote it out, is that the parameter is connected to the population. They both start with the letter P. The sample was the 62 GHC students that were enrolled in Stat 1401 in fall 2021. And it was definitely a convenient sample because Miss Ralston, I had access to those students and asked them to complete a survey. It is representative because I used students at GHC in fall 2021, which are the three primary characteristics of the population that should carry over into the sample. It's random. Even though we used a convenient sample, it's random because any student at the college in fall 2021 could have enrolled in Stat 1401. I apologize, I got the yawns this morning. Connected to that sample then is the statistic. And remember, the statistic is the same measurement as the parameter, but it is connected to the sample. So it's the average age in years of the 62 GHC students enrolled in Stat 1401 in fall 2021. And then we had, or I gave you the list of data. Okay, I gave you this list of 62 ages. And I commented then that we were going to look at how to create initially a table. A table in statistics has a fancy name. They call it a frequency distribution. Specifically, we use a grouped frequency distribution where we use a range of values for each group or each class, if you will, not an individual value, because we noted that these values go from a low of 18 to, I believe the high was 57. And I didn't want to list out 18, 19, 20, 21, 22, 23, go all the way up to 57, because there were a lot of values that I might not have an age for. And so we grouped it and we walked through how to get those groups. Now, I will tell you, for class participation 5, which we're going to take a look at a little bit later today, and on the test, you are given the groups. Okay, I go ahead and give you this setup for the groups, because if I don't, then each individual student could set it up a different way. And so for consistency, for ease of grading, I tell you what groups to use. We noted that we had to have a starting value that would be low enough to include the lowest value in the data set, and then we have to go high enough to include the highest value in the data set. I encouraged you to use what I would call nice, neat numbers. Again, thinking about ages, for nice, neat numbers, I think of things that end in 5 or 0. So we started, our lowest age was 18, so we started with a value of 15. We decided to count by 5s. We could have done 10s. We're open to various things. So we set up our levels, our classes. Remember, each row is a group or a class. So this one we had 9 classes. We then went through the list and indicated how many times a number within that group occurred. We converted those to a count as opposed to a tick mark, and then we calculated the relative frequency. It's important to remember that the total frequency should equal the sample size, and the total relative frequency would equal 100%. That was also true when we talked about categorical. Remembering that our goal was to answer the question, what is the average age? The table didn't necessarily help us do that. Okay, we can begin to learn some things about the data set. We noted that, about 75% of the students are younger than 25. It would be unusual for a student to be 45 or older. So again, just kind of getting an idea, we thought that the average is probably somewhere between 15 and 24. Now, I'm sure there are technologies that would set this table up for you. Okay. Minitab does not create a grouped frequency distribution. So this is one thing that you need to be able to do, in a sense, by hand, paper and pencil, for class participation 5. On the test, much like if you've taken test 1, you'll be given the frequency distribution and you'll be asked to interpret it or read information from it. Okay, so the only time you're going to be asked, at least in this course, to create one is on class participation 5. And again, I give you the setup. Okay. Then we began looking at some of the graphs, and you may wonder, well, why do we need to use graphs? Is the table not enough? It does organize the data, but quantitative data is a lot more involved than the qualitative data. With the qualitative data, once we got the table, we were able to answer the question. But with numbers, numerical data, quantitative data, there's a lot more analysis that needs to be done. And graphs can be even more useful to provide lots of information to your audience, to your reader, very quickly. If you think about it, a lot of newspapers and the internet, even on television, they're going to use graphs because they're easier to see trends, whether something is increasing, decreasing, or staying the same. It also allows people to compare things, facts and figures, very quickly. Unfortunately, within the world of statistics, there's not a set of strict or rigid guidelines about which graph to use. When should we use a stem and leaf plot? When should we use a histogram? When should we use a box plot? Quite honestly, it's going to depend on what information you need and or want to share with your audience. There are a lot more than the 3 that we are going to focus on. We're focusing on stem and leaf, the histogram, and the box plot. We walked through the stem and leaf. One of the benefits of a stem and leaf, which to me is almost like a table, a different form of a table, but this text views it as a graph. It allows us to retain the raw data. I could go back with this stem and leaf plot that we created the other day and create my list of data. I could recreate this list if I needed to. I cannot do that with my frequency distribution or my table. So again, the stem and leaf also, I noted for you, allows you to organize the data low to high. One of the things that I remembered this morning as I was kind of reviewing and preparing for our discussion today, one of the things that I did not tell you about a stem and leaf that you might find important is that a stem and leaf is really best for what we call small data sets. We had 62 data values. That was okay. Probably it was really too many. Okay, but a stem and leaf plot is really a better option when you have what we consider a small data set. Ideally, small is less than 30 in terms of statistics. So I did it with 62. It's a little bit outside of probably, where I would want to do it. The biggest thing with the stem and leaf, remember, is it kind of breaks your number apart really by place values. Your leftmost digit becomes the stem, and they're listed vertically in the column. I'm reviewing this because I know that you have to do this on class participation 5, which we're going to do here in a few minutes. The leaves are your rightmost digit, or the remaining right side digits, and they're listed horizontally next to the appropriate stem in numeric order, so that I could tell you from looking at this stem and leaf that we created the other day. I know that the youngest student in Stat 1401 in fall 2021 was 18. I know that the oldest student was 57 from my sample. The stem and leaf is a little bit better maybe than the histogram we talked about, because I could again determine my definite lowest value, my definite highest value. We could see which data value occurs the most. We were able to find the one that was in the middle. And again, we could estimate that we think the average is somewhere between 18 and 29. We could also talk about it, we didn't the other day, but if you think about drawing boxes around each row and creating a bar graph, we could think about the shape or the distribution of the graph. And remember, we learned about 3 different distributions right at the end of class on Monday. They were skewed left, symmetric, and skewed right. And if I think about it, I have a lot of these data values on the low end. And when I have a lot of data values on the low end, if you go back and look, that is skewed to the right. So if I picture this kind of like a horizontal bar graph, then I can begin to think about the distribution as well. Minitab will do a stem and leaf. It may look a little bit different, and I'll show that to you in just a few minutes. Then we began talking about the histogram, which I noted was similar to a bar graph, but you have no gaps between the bars. Your horizontal axis is your groups, which is your range of values. Minitab specifically uses the class midpoint. The vertical axis was your frequency or relative frequency, and any graph you create should always have a detailed descriptive title. And I drew it, kind of rough sketched it by hand for you. And then we got into the different distributions. So I want to go back over to the PowerPoint for just a minute and review those 3 distributions. For skewed to the right, we said that most of our data values are on the low end and it tapers off to the right. So again, if you look at this histogram on the example that I have on the slide, and think about it again, your hump is on the left-hand side because you have lots of low values and very few on the high end. Okay, so again, remember your scale runs low to high. That's skewed right. In my mind, I think about it being backwards. If it's humped on the left, it's skewed to the right. Humped to the left, it's skewed on the right. Symmetric is kind of what we oftentimes think about as a bell curve, where that you have very few data values on the low end. Most of them are in the middle and very few values on the high end. Most everything is kind of centered in the middle. And if you could imagine folding the graph in half, the left side would look like the right side. A great example of this distribution, when you hear instructors or professors talk about, quote, grading on the curve, they're trying to get this kind of distribution where they have a lot of C's, you know, a good bit of B's and D's, but not very many A's or F's. So if you think about this like grading on the curve, let me change colors. This would be like you have, you know, a lot of C's in the middle. You have, you know, some B's, a good many B's and D's, and very few A's and F's. The last one is skewed to the left. And again, with skewed to the left, you have very few low ones, but then you have lots of high ones. And again, the hump, as I think about it, the hump is on the right-hand side, but again, it's backwards to what my brain would tell me. If it's humped on the right, it's skewed to the left. Humped on the right, it's skewed to the left. And you may think, well, Ms. Ralston, who cares whether it's skewed left, skewed right, or symmetric? But knowing what shape distribution you have later on can affect or even determine what analyses you can and cannot use. We really can do a whole lot more analysis if we have a symmetric distribution, one that kind of looks like that bell. If we have a skewed distribution, we can still analyze it, but we don't have as many options. So it's important to think about what those characteristics are. So that's kind of a quick review, kind of a quick summary of the discussion from the other day to kind of get us back into where we're headed today. So do you have questions? Okay, one other thing that I want to do, if I can get to it, is to talk about whenever we begin analyzing data. Okay, so we've kind of talked about how to organize it. There is one other graph that we're going to talk about called a box plot, but we're not ready to talk about it yet. Hopefully we will be towards the end of our discussion today. But when you begin to analyze data, which is the next step, we've posed our question, we've identified the variable, the population, parameter, sample, and statistic. We've collected the data, we've organized the data. Once you get it organized, the next step, the fifth step in the process, is to analyze it. And when you analyze data, there are 5 characteristics or 5 things that you want to focus on. And I have them listed here on this PowerPoint slide. This comes from the first lesson in Module 2 on quantitative data. The 5 important characteristics are the center, the variation, the distribution, outliers, and time. The center is kind of that representative or middle value. It's what we often refer to as the average. So the measure of center kind of indicates where the middle or the most representative value is for the data. Variation is a measurement of how much the data values differ or vary among themselves, but we can also see how they vary from data set to data set. Third is the distribution, which we've already talked about a little bit. The distribution is the shape of the data. Again, are they all clumped on the low end? Are they clumped together on the high end? Or are they clumped together in the center? Again, those are the three distributions: skewed to the left, skewed to the right, and symmetric. Then we have outliers. Outliers are data values that just don't seem to fit. They don't go with the rest of the data. You know, if we're again looking at ages of students in fall 2021, and I had a student that was maybe 80 years old, that's a little odd and would likely be very unusual that you would have a student that was age 80. You could also have one on the other extreme. You know, maybe you have that child genius and you have, say, a 12-year-old who is enrolled as a college student. And so that would be very unusual. So an outlier is a data value or possibly values that just don't seem to go with the rest of the data set. And they can be on the low end, they can be on the high end, or you could have them on both at the same time. The thing about outliers is sometimes they kind of sneak up on you. Values that you wouldn't necessarily think are outliers actually are. And so we're going to talk about how to make that determination. And then the last characteristic is that data changes over time, which hopefully makes sense to you. Think about the stock market. You know, the price of a stock can change from hour to hour, day to day, week to week, month to month. Even if we consider the question we're looking at now, we're looking at the average age in fall of 2021. If we looked at what the average age was in spring of 2023, we may or may not get the same value. It could have increased or decreased. It could change over time. A lot of that depends on the age of students. Sometimes, a lot of times, depends on what's going on within the economy. Because at times when the economy is kind of bad and people are losing their jobs or being laid off, one of the things they'll do is come back to school. And so you sometimes get a number of older students. So that's something that you have to think about. Time is probably the one characteristic that we do not focus on a great deal in this course because we don't have time. It's an 8-week course, and so that's not something that we spend a lot of time focusing on. Okay, so what I want to do next is I want to go over and get into Minitab and talk about how to create these graphs in Minitab. Because let me show you, let me pull it up if I can. I think I had it pulled up earlier, but maybe not. For class participation 5, which I'm going to have you do in just a minute, you're going to use the survey results from the class, and you're going to create a grouped frequency distribution based on the last letter of your name. So for example, I know that Alexis is in the room. Her last name is Hammock. which starts with an H. So her last name ends, I should say begins, not ends, but begins with a G, or begins with a letter between G and L. So she would do hours employed per week. That's the variable she's going to focus on. And Miss Ralston has given her the groups that should be written in column 1. Okay, and then she can figure the frequency and relative frequency. Then you're asked to create a histogram in Minitab. So I'm about to show you how to do that. And then you have to answer some questions about whether the histogram is skewed left, skewed right, and then make a reasonable estimate of the variable. What do you think, the average number of hours that students work? Okay, so you need to understand or know how to create a histogram in Minitab. So you were given in this problem the data set. We have the raw data. Many of your homework problems in D2L will give you a data set such as this. You have to physically, with your fingers, type that data into Minitab. Okay, so I opened up Minitab. Let me remind you how to get there. app.minitab.com. Now I'm already logged in, but normally when you hit enter, it's going to ask you to log in. You must use your Georgia Highlands email address and then the corresponding password, and it does go through Duo security. I showed you that last class. Okay, I went ahead to save us a little bit of time and started typing these, but you go to the lower half of the right hand side to kind of the spreadsheet area. One of the things that's important, and I waited to do this, remember this little grayed out area between the column label and the first row is where we tell ourselves, tell an observer, another researcher, what that data is. So this is ages in years, and that's probably enough, but if I want to put for GHC students, I can do that. Okay, but I definitely want to indicate that these are ages and that the measurement is in years. And then I started in the first column and I went down the column and I've entered the data. Okay, I just started typing the numbers. And again, I've typed most of them. I was going to show you a few. So I like entering the last column. Okay, so I'm on the last column that starts with 24. So I would just type with my fingers, 24, 21, 18, 20, 33, 21, 35, 19, 54, and 50. Now, guys, if I'm doing this for an assignment on my homework, on the test, I want to kind of scan back through. I really should look at each individual value and make sure that I didn't, type something crazy or have something entered, incorrectly. I want to make sure they're all 2-digit numbers. So you want to check and ensure that you entered the data correctly. Okay, so when you're given a data set, before you can do anything in Minitab, you have to enter the data. You must be sure that you label the column to indicate what that data is and then enter the data. I can tell, notice that when I've typed the last number, I was on row 62. And I know that I had 62 values. So I at least know I typed them all. And again, I should scan them to ensure that I didn't mistype or type something really wonky. Where did my numbers go? Oh no. Okay, there we go. Okay, we want to create a graph. Again, I mentioned to you the other day that Minitab is fairly common sense if you'll think about it. We want to create a graph. So we go to Graph, and when I click on it, I get a list of all the different types of graphs Minitab will create. I'm asked to create a histogram. So I'm going to choose histogram. Again, for our purposes in this course, we keep things as simple as possible. So we're going to do one y variable. I've only got one variable, and I'm going to keep it simple. I have to choose the variable. Now, I only have one variable in the system right now, but if I had a whole spreadsheet, I would need to choose the one I want. So I want ages in years. We can have it do some fancy stuff, but we don't need to. I'm going to check options. I don't need it to do anything fancy, so you really wouldn't even have to click that. And then I click OK. And in the top half of the screen, your histogram appears. Notice that by default, whatever you put as your label for the column is now the label of the horizontal axis. The vertical is the frequency. Minitab labels it histogram of ages. It's a title. It's not a detailed descriptive title. So I want to change this title to make it more descriptive. Okay, to do that, notice how I have my graph selected and there's this dark black or dark blue square around it. In the upper right hand corner, you should see a little upside down triangle. I'm going to click on it. And it gives me some options for my graph. So I'm going to click Graph Options. And then I can change the title. I want to make it more descriptive. So we're looking at ages in years of GHC students. I could go ahead and say in fall 2021. I could use a subtitle and indicate fall 2021. You could do it either way. And notice how it changes over here actually on the graph. Again, that title is more detailed. It tells me who, it tells me where, it tells me when and what. You need to change the title to be detailed and descriptive. Once you have it titled, okay, a couple other things I want to point out. Notice that, as I mentioned to you before, Minitab is using the midpoint. If I put my mouse on this blue bar, it tells me that that bar represents ages 17 and a half to 22 and a half. See, it says Ben 17 and a half, 22 and a half. It also tells me that there are 39 values in that group. So there were 39 students between the ages of 17 22.5 and 22.5. If I scroll over the next one, it tells me that it's the bin 22.5 to 27.5, and there were 9 values. You can go way over here to the end. I had the bin 52.5 to 57.5, and there were 2 values. So it's a little bit interactive when it's still in Minitab. And you can learn information by hovering your mouse over the bars. For class participation 5 and for other assignments as we go throughout the course, you need to be able to take this graph out of Minitab and put it into a Word document or into a PowerPoint, that sort of thing. Guys, it is just like Word or Excel. It's a copy and paste. So again, I select my graph by clicking in an area around it. Again, you'll notice the dark black or blue lines around it. Again, I'm using the triangle in the upper right corner, and I want to tell it to copy. I want to copy the graph, and then I'm going over to my document, whatever document that is. And I paste. Now, once I paste it, it's no longer interactive, but it's in the document. Okay? And then we can think about it. We noted yesterday or on Monday that we thought the distribution was skewed to the right. And if you look at it here in Minitab, or if we go back over here to the Word document and look at it, again, notice how we have a lot of data values. If you want the curve, how we have a lot of data values at the beginning on the low end, and as we move out to the higher ages, it tapers off. So again, that hump is on the left, which means it is skewed to the right. Now, as far as estimating what I think the average might be, again, we've kind of said we thought it was somewhere between about 18 and 29. Well, if I look at this bar, I had 39 values, which is over half in this bin that went from, what did they say? I have to go back and look. 17.5 to 22.5. The middle value there was 20. So I might now say that I think that the average is approximately or somewhere around 20. Now, again, I'm estimating, but I'm in the ballpark. I'm not going to estimate that it's up here at 35 or 40. And I could have said, well, maybe it's like 22 or 21. I just picked this nice number that was on the scale. But again, because over half of them are in this first bar, I'm probably going to pick some value in that first bar to be my average or my representative value. Questions? Okay. The other thing that I want to show you, because you're going to need to do this for class participation 5 and for other assignments throughout the semester. And I want to go to a different worksheet. I don't want to lose this one. Okay, so I still have worksheet 1, worksheet 2. Okay, remember in D2L, I have posted the class participation survey results. Those are the results. That is the data you're going to use to do class participation 5, 6, 7, 8, 9, and so forth. Okay, we're going to use that real data that was collected from students in Stat 1401 for spring 2023. So the first thing I need to do, I don't want to have to retype all of it, but I can copy and paste it into Minitab. Now, the downside is if I don't save it, I have to copy and paste every time. Okay, so I'm going to go to the announcement that says class participation survey results, and I'm going to download the attachment. So I'm going to double click, on the attachment, and then I'm going to save it. Now I have a folder on my desktop called datasets. You can put it on your desktop, you can put it wherever you want, but wherever you put it, remember where it is. So I'm going to put mine in my datasets folder. So once I get it downloaded, then I'm going to go to that folder, if I can find it on my screen. Where's my datasets folder? Okay. Once it's downloaded, I'm going to open it. Okay. So here is the spreadsheet. I want to copy all of the columns at one time. If you go to the corner in the upper left where your columns and your rows meet, it's like a little triangle. I'm going to click there. When I click there, it highlights the entire spreadsheet. Then I'm going to copy. So I'm going to choose the option to copy. And you can see it. There's like little dancing ants all the way around the spreadsheet. So I've copied it. Then I'm going to Minitab. And I've got me a nice, clean spreadsheet. Nothing on it. I'm going to put the mouse in the header under C1. Put the mouse in the header under C1, and then I'm going to paste. And all of the spreadsheet has been copied. Again, for Alexis, she's going to be doing hours employed. So she's going to focus her attention on column 8. Let's see. I'm not sure who else is in the room, so let me see. Luciana, I don't remember what your last name starts with. What's the first letter of your last name, Luciana? M. Okay, so Luciana's last name starts with the letter M. Thank you, ma'am, for telling me. Okay, and so she's going to do credit hours, because if your last name begins, I need to change that word, with the letter M, you're going to do credit hours. And again, I've given you the groups. So the groups, you're just going to take what Miss Ralston has in the top and put in the first column of the table. Okay, and then you're going to focus your attention on column 7. Y'all with me? Now, the downside is then you have to kind of go through, I've given you the groups, so you're going to go through. Oh, where did it go? Oh, good heavens. Give me just a minute. Okay. Okay. Then you got to go through. Okay. There's a 13 for credit hour. So I'm going to mark a tick mark. There's 6. You know, you're going to go through this whole list. When you're done, you should have, let's see how many data values we have in our data set. You should have 81 data values. Okay. When you're done, you should have a total of 81 data values. Okay. So I want to give you guys a few minutes to start working on that to make sure that you're on the right track and you can ask questions. Okay. So by my clock, it's 10:22. Okay. So let's work till about 10:40. Okay. During that window, maybe if you need to take a quick break, get a drink of water or whatever. If you have questions, I'll be happy to answer those. You can put them in the chat or you may unmute and speak. I am going to step out for just a minute and then I'll come back and I'll check the chat and see if you have questions. Thumbs up, are y'all good? Okay, I'm going to mute my thing and I'm going to pause the recording, but if you have a question, you can put it in the chat or you can speak when. Based on my clock on the computer, it is 10:40. And so I want to pick up our discussion and we're going to continue into the next lesson for in module 2 entitled Descriptive Statistics. And I mentioned earlier, let me share my screen. I mentioned earlier that when we are analyzing data, there are 5 characteristics that we want to focus on. They were center, variation, distribution, outliers, and time. And so we're going to talk about how do we find those measures of center, measures of variation, what are they, and that sort of thing. And so that gets us into the realm of what we call descriptive statistics. So I'm going to outline those. They are detailed for you in the PowerPoints. There's one for measures of center, there's one for measures of variation, and there's also one called measures of position or relative standing that connects to some of our topics. So we'll be talking about those over the course of the next few minutes or the next hour or so. Hopefully we can get through all of them today, but I do not know if we will be able to do that for sure or not. So we're going to begin talking about the overarching topic here is descriptive statistics, which if you'll remember is one of the branches of statistics. But in this case, it's referring to the values that describe the data set. Remember, in the world or in the branch of descriptive statistics, we want to state just the facts. How many data values do we have? What data value occurred the most? We want to think about what is the average or what is those particular values. So we're going to begin by talking about what all those different measurements are. And we begin by talking about the measures of center. And there are 3 measures of center that we use for the most part throughout statistics. There's really a 4th one, but it's not very useful, and so we don't really talk about it a great deal. The first one that we talk about is the mean. The mean is what most people refer to as the average. The formal phrase is it's actually called the arithmetic mean. We find the mean by adding all of the data values together, okay, and then dividing by how many we have. But again, it's what most people think of when they think about the word average. Of the three measures of center, the mean is the most important. It is the most important because of two reasons. One is because all the data values are used in its calculation, so we're not leaving anything out, okay, and because it's used in other statistical calculations or formulas, if you will. So if you're limited on what descriptive statistic you can calculate, ideally you would like to calculate the mean, because the mean includes all of the data values. Now, because it does use all of the data values in its calculation, it can also be influenced or affected by outliers. Okay, so that can sometimes be a challenge because your mean can be affected by outliers. It can cause the mean to be inflated or deflated. It can cause your mean to be higher than it should be. Again, if we have that 80-year-old in the class, so you have an age of 80 and most everybody else is down around in their teens and 20s, then that's going to cause your average to be higher than it really is. It can also cause your average to be deflated. If you have that 12-year-old in the class, then that can cause it to be lower than it should be. So you have to be careful. While the mean is the most important, it's really the best measure of center. It may not be feasible to use it if your data set contains a large number of data values. Now, we do talk about the population mean and the sample mean. You can have the mean that is connected to the population, which is your big picture focus, and you can have the mean that is specific to your small group focus. We distinguish those, one by using the phrase with the adjective population mean or sample mean. We also distinguish it with the notation or the symbols used for those values. Typically, anytime you're dealing with a population, whether it's the mean or the standard deviation or some other measurement, if you're dealing with the population, we use Greek letters. Okay, so one way that we identify that we're dealing with a population is via the notation. And if we're dealing with the population, we use Greek letters. If I'm dealing with the sample, we use English, your text refers to them as Roman letters. And we don't necessarily have symbols for every single descriptive statistic. We do for the more important ones. Since the mean is an important one, we do have a symbol. For the population mean, we use the letter mu. It's the Greek letter mu. It's actually the lowercase m in the Greek alphabet. So the symbol for the population mean is the Greek letter mu. It kind of looks like a fancy cursive U. For the sample, using English letters, we use the letter X and we put a bar over it, and we read that as X bar. So again, sometimes when you're reading professional journals, reading a research report, you may see those symbols. And again, the fact that it's a Greek letter should let you know that it's a population, and if it's an English letter, that they're dealing with the sample. Now, Minitab is going to calculate this measurement for us. Okay, I'm going to kind of make notes as we go about whether Minitab does it or not. Minitab does this one. Okay, again, most researchers in today's society do not do manual calculations. They don't use, paper and pencil. They might use a calculator. There are other technologies, but again, for our purposes throughout the semester, we're going to use the statistical software package Minitab. So I'm going to use Minitab to do that. The second measure of center that we think about is the median. Okay, the second measure of center is the median. The median is the middle data value when the data is ranked. When the data is put in order from low to high or high to low, okay, the median is the middle. In my mind, I always think about the median of a road, and typically the median of a road is in the middle. Sometimes that median is a grassy area. Sometimes that median might just simply be a concrete barrier, but the median of a road is in the middle. The median basically divides the data 50-50. You would have half or 50% of your data values below the median and 50% above the median. Okay, so you're looking for the middle when the data is ranked. It doesn't really have a special symbol. If I'm not mistaken, again, I know Minitab calculates it. So Minitab's going to do this calculation for us. One of the benefits of the median is that it is not affected by outliers. So sometimes when you have outliers, we may use the median instead. It's not affected because you're not actually performing a calculation. You're just locating the data value that's in the middle. The third measure of center is the mode. The mode is the data value that occurs the most. The mode is the only measure used with qualitative data. Okay, the mode is the only measure that we use with qualitative data. We can think about which category occurs the most. And so it is the only measure out of all of them that we talk about that is used with qualitative data. Notice that I wrote data value and then I put the S there because you can have more than one value that occurs the same number of times. Like if you have a tie between two categories, you can have more than one. So it is possible to have more than one. It's also possible that you have what we would say is no mode. There may not be a value that occurs more so than any of the others. And so in that case, you have no mode. And you really should use the word no, not the number 0, because again, 0 would make you think that that value is the one that occurred the most. So just be careful about that. So Minitab does also calculate the mode for us. And those are our 3 measures of center. Now I'm going to go over to the PowerPoint related to measures of center. Again, all this information is here. One of the questions we often get is, well, which one should I use? And quite honestly, there's not a definite single answer to that question. Quite honestly, it depends upon what you're trying to do. You may have to decide as the researcher which one you think is most representative. Again, there are some guidelines you can use because, for example, if you have outliers in the data set, remember outliers can affect the mean. So maybe if I have a lot of outliers, I want to consider using the median instead. If I'm dealing with qualitative data, my only option is to use the mode. Oftentimes we want to avoid using the word average because statistically an average could be either the mean, the median, or the mode. It's better, especially if you're writing a research report, that you're specific. Sometimes I've seen reports where they say the median average is, or the mean average is. Again, they're emphasizing which measurement they use. And again, I've tried to point out the advantages and disadvantages of each one, and that's going to be what helps you to decide which measure to use. The other thing that is we can use the measures of center for is I mentioned to you on Monday that for the different distributions, if we go back and look at the different distributions that we could have, whether it's skewed left, skewed right, or symmetric, I mentioned to you on Monday that we were doing that basically with our eyeballs. Okay, if you're just looking at it, looking at the graph with your eyes, you can kind of maybe get a good estimate or a good reasonable answer, whether it's skewed left, skewed right, or symmetric. Sometimes it's very obvious. The example that we looked at this morning with the ages, if we go back to that particular histogram. Okay, that one was reasonably obvious that it was skewed to the right. But sometimes you get some that are really, you're kind of like, well, it might be skewed right or it might be symmetric. So with our eyeballs, and I think I talked about this, it's open to interpretation. By the viewer or by the researcher. But I can use the relationship, the comparison between the mean, the median, and the mode, those three measures of center, to help me verify, confirm whether or not my distribution is skewed left, skewed right, or symmetric. Making that determination is important, okay? Because then that verifies it. Plus also, remember, I told you it's important to know what distribution you have, because that can affect your analyses, what analyses you can and cannot do. So we also have kind of a verification process, if you want to call it that. Okay, where we're using the numbers. We're not relying on our eyeballs. With the verification, we compare the three measures of center. Now, that I have it on the PowerPoint, and I'll even tell you what slide numbers. It's on the PowerPoint. It's slides 13, 14, and 15 for lesson 2. Okay, but I'm going to do it here on these graphs that we drew on Monday. Okay, so if you're thinking about skewed to the right, again, we've noted that that means you kind of have that big hump on the left-hand side. It's called skewed to the right. If I'm looking at the comparison between the mean, the median, and the mode, okay, I would have the mode is first, then the median, and then the mean. Okay, so let me go over here to the PowerPoint. If we're talking about skewed to the right, again, the mode would be first, then the median, then the mean. So you can kind of see it written out. Okay, so it's the mean, the mode, the median, and then the mean. So the mode is the smallest, and it's smaller than the median. The median is smaller than the mean. That is skewed to the right. They kind of, if you think about ranking them, mode is smallest, median is in the middle, because remember, it's the middle value, and then the mean. So I can compare those. And we'll do that in a little bit. For symmetric, with symmetric, it's kind of like you have that one peak in the distribution. And so our mode, our median, and our mean are all approximately the same value. Now, that may not be dead on exact, okay? But they're reasonably close or equal to one another if it's symmetric. They're all three the same. And finally, with skewed to the left, you would actually have the mean is the smallest, then the median, and then the mode. Notice in all three cases, the median is in the center or the middle, because remember, it's the measure of center that represents the middle value. So in this case, for skewed to the left, the mean is the smallest, then the median, and then the mode is the highest. So the mean is smaller than the median, and the median is smaller than the mode. So not only do those measurements help us to begin to analyze our data set, they also help us to verify or confirm what shape distribution we have. And I'll show you how to do that when we get through talking about our different measures of center and measures of variation. The next grouping of descriptive statistics is called measures of variation. Measures of variation. Remember, the idea or the characteristic of variation gives us an idea of how much the data values vary among themselves, but we can also use it to determine how much they vary from sample to sample. Is one sample less, does it have less variation than another, or does it have more variation than another? So variation has to do with how much the data values differ within or between data sets. And there are three of these. The first measure of variation is the range. Okay, and that's probably one of the measures that you've heard of before. The range is simply the maximum value minus the minimum value. It's a very quick, easy calculation to give you an idea of the spread. Sometimes you'll hear this referred to as the spread of the data set. Again, and it's kind of all relative, but if the range is what we would consider a reasonably small number, say like 5, then that gives me the sense that there is little variation within the data values. But if I have a range of 50, then that would seem to imply that I have a lot of variation within the data set. So it's a very quick and easy calculation. Minitab will do that for us as well. There's not a fancy symbol. For the range. The second one here, second measure of variation, is called variance. The variance is what we call an unbiased estimator in the world of statistics. It means that basically if I'm able to calculate the variance for a sample, that sample variance is on target for what it would be for the population. It's like I'm hitting the bullseye every time. Regardless of my sample, the value that I get for my sample variance is like hitting the bullseye for what it's going to be for the population. The challenge with the variance is that it is difficult to interpret because the units of measure are squared. So if we're thinking about the ages, we would have to think about ages or years squared. If we were talking about money, we would have to talk about dollars squared, which is a very unusual idea in our mind because we don't normally think about those things being squared. And I don't usually spend a lot of time on the theory behind the calculations. I don't even usually show you the formula. But I think you need to kind of have an understanding of what's going on. The variance is kind of the average of the difference of each data value and the mean. Okay, so here's one case where we're actually using the mean to calculate something else. And so the variance kind of gives you an average of that difference. So I want to go over to a clean sheet of paper and kind of see if I can walk through the theory, if you will, behind the calculation of the variance. Now, I'm not going to get overly technical, but again, I want you to kind of get a sense of what's going on. So let's say that we have the data values, and I'm going to keep it simple. 1, 2, 3, 4, and 5. So those are our data values. I'm going to calculate the mean of those data values. Now remember, to calculate the mean, we would add them up and divide by how many we have. So if I say 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So when I total it up, I get a total of 15, and there were 5 values. So 15 divided by 5 is 3. So the mean for those 5 numbers is 3. I'm then going to compare each one of my data values to the mean. We make a comparison by subtracting. So I would have 1 minus 3, which gives me -2, because 1 is 2 units below the mean. 2 minus 3 is -1. I'm 1 unit below. 3 minus 3 is 0 because it's the same. 4 minus 3 is 1. I'm 1 unit above. And 5 minus 3 is +2 because I'm 2 units above. So this kind of shows me that I have some data values that are above, some data values that are below. But guys, if I try to add those up, and let me change colors here. If I try to add those up to see what my difference is overall, if I try to total this, -2 plus -1 is -3, plus 0 is still -3, plus 1 is -2, plus 2 is 0. So I get a value of 0, which implies there's no difference in those data values. Well, that's kind of crazy because I can tell there is a difference. I mean, 1 is different than 2, is different than 3, is different than 4. And so mathematicians, statisticians kept butting up against that problem. And so they wanted to force all of these values to be positive. And so after they took the difference, they squared them. So -2 squared gives me 4. -1 squared gives me 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So now all of my numbers are positive. And if I add those up, I get a value of 10. And then I divide, and the rule's a little wonky. You divide by the number you have minus 1. So I'm only going to divide by 4. So when I divide 10 by 4, I believe I get 2.5. Let me see. Is 2.5. But this would be 2.5 units squared. Again, if I were talking about money, we would say $2.5 squared. If we were talking about ages, we'd have to say years squared. Okay, so because of the idea that we're looking at the difference, okay, by subtraction, and that led us to getting a 0, we introduced the squaring, which then makes it challenging to interpret. But again, what we're doing, what I've done here is find the average of the difference. So that's kind of the theory. Again, I don't normally do a lot of theory behind the variance. Okay, but again, because the units are squared, it's difficult to interpret. The variance is one of the most important, is another important one, and so it does have a symbol. You have the population variance, and you have the sample variance. Again, remember, population is Greek letters. We use the Greek letter, it's the letter O. It's called sigma, and we put an exponent of 2. We read this as sigma squared. If it matters, that is the lowercase sigma. Okay, for the sample variance, we use S and then the square. So we read it usually S squared. Minitab will calculate it. Okay, so you don't have to really know the formula or that process that I was just demonstrating for you. Be thankful. Miss Ralston used to have to sit and do those hand calculations and create that table. Variance, one other side note that may help you when you're looking at values to maybe realize you've made a mistake, is that the value for the variance will always be positive. Again, because we introduced that squaring and we forced everything to be positive. So if for some weird reason you get a negative value, that kind of clues you in, whoops, I've made a mistake somewhere. So again, it's difficult to interpret the variance. So that actually leads us to the third measurement, which is the one we use probably most often. The third one is called the standard deviation. And by definition, the standard deviation is the square root of the variance. If you'll remember from algebra, a square root will undo, cancel off a square. They're inverses of each other. So if I take the square root of whatever value I got for the variance, that gives me the standard deviation. And the benefit is I am back to the traditional units. Okay, so one of the benefits of the standard deviation is that the units are no longer squared, which benefits the interpretation. The interpretation is easier or makes more sense. The standard deviation is similar to the mean in that it is the most important of the three measures of variation. And it's actually the most important for the same two reasons, because in the calculation of the variance, aka the standard deviation, we use all the data values, because all the data values are used in the calculation, and the standard deviation is used in other statistical calculations or formulas. So for the same two reasons, again, if I'm very limited on what I can calculate, then I want to think about definitely the mean and definitely the standard deviation. Again, Minitab is going to do this for you. Because it is one of the most important of the three measures of variation. Again, you do have symbols. You have, again, a symbol for the population standard deviation, and you have a symbol for the sample standard deviation. Again, population is always Greek letters. It is the Greek letter sigma. I'm going to make a note here that it's lowercase. And for the sample, it is S, and we just say S. Those are your three measures of variation. I did not pull that up, but it is lesson 3 under module 2. Okay, so let me see. Lesson 3 under module 2. And again, you get the emphasis on how to interpret them. One of the things I'll point out here is that, how do we use the variance or the standard deviation? Again, those two are probably the most useful. Again, it gives us an idea of that spread. It's probably a little bit more accurate than the range because I'm using all of the data values. Again, if that variance value or the standard deviation is what we would term large, that implies that my data is very spread out or dispersed. If it is small, or what we would consider small, that means that my data is closer together. It's not as dispersed. You'll also see variance and standard deviation used to determine what is called consistency. Again, the idea, if you're manufacturing things like nuts and bolts and you want the variation in the diameters to be small or consistent so that everything will still fit together. Okay, and so that helps you to determine the consistency. There has to be a specific allowance, is probably what you've heard it called, on either side. If you want it to be a certain value, sometimes we have an allowance on either side so that it could vary or be off a little bit. And so that's called consistency, especially when you're thinking about manufacturing. Okay, so that's the three measures of variation. Then we get into the lesson which is entitled Measures of Position or Measures of Relative Standing. Okay, so let's go back and talk about these. We have measures, and I can't remember which word is used in the lesson. I'll try to look it up in just a minute. Measures of position, or sometimes they're called measures of relative standing. These are used to help compare values from different data sets. Again, measures of position allow us to compare a single value to the population. You'll see this used a lot in things like psychology, sociology, any kind of standardized testing where you want to compare how an individual has performed against what they call the norm or the national norm. So it allows us to compare a single data value to the population. It also allows us to compare data sets from or data values from one data set to another data set. Now, let me see if I can look up real quick what term is used in our lesson, because I honestly don't remember. This would be lesson 4. Okay, this text uses the measures of position. We also, the third thing, and it says it here on this PowerPoint, we can compare data values from different data sets, which I mentioned. We can compare them within the same data set to the population. But we can also use our measures of position to help us determine if our data set has outliers. Our gut, our instinct may tell us, I think that value might be an outlier. But again, the measures of position is a verification of what our gut may be telling us or wanting us to recognize. There are 2 different types of measures of position that we're going to talk about. One of them is called z-scores or the standard score, and the other one is called percentiles. So let's talk about the z-score, or it's sometimes referred to as the standard score. Basically, what a z-score does is it lets you compare data values from different data sets that are on different scales. Okay, it allows the comparison of a data value or values from different measured or measurement scales. For example, if we were measuring the heights of people and okay, so our example is we're going to do, let's say, heights of 18 to 24-year-olds in the United States and in Europe. Okay, so we want to compare the heights of 18 to 24-year-olds that live in the United States to those that live in Europe. So when we go to collect our data, typically when you collect data in the United States, our heights are going to be, usually we would say things like 5 foot 6 inches, which could be converted to 66 inches. You might have, 5 foot 2 inches, which we could say is 62 inches. So most times our heights could be stated in terms of inches, or we have it in terms of foot and inches together. But when I go to Europe and measure heights in Europe are most likely going to be in centimeters or in maybe meters. Probably centimeters would be more likely. So you might have things like 168 centimeters, or you might have things like 157 centimeters. Okay, so you have two different measurement scales, and because of that, we cannot compare them directly. I can't compare inches directly to centimeters. They're not the same size. In fact, 1 inch is 2.54 centimeters, if you're familiar with that conversion. And so if I really want to make a comparison, I need to have them on the same measurement scale. And so what a z-score does is it converts everything to the same scale, and the scale that it converts it to, okay, the units that are used by a z-score is the number of standard deviations. It's a formula, okay, to calculate a z-score, and this is usually a calculation we do by hand. We would take our data value minus the mean and then divide it by the standard deviation. Okay, so we take our data value of interest, we subtract it or compare it to the mean, and then we divide by the standard deviation. And you can do that whether you're using the population or whether you're using the sample, either way. But again, that gives us a value, and again, everything is then in terms of standard deviation. And I can compare apples to apples or oranges to oranges. Now again, this is typically a hand calculation using the formula, okay? It's not something Minitab does. This is a hand or calculator issue. Minitab does not do these calculations. The use of z-scores you don't necessarily see as much anymore because of the advent of technology. When I was coming through, we used z-scores almost religiously, almost on a routine basis, pretty much for everything. But again, with the advent of technology, some of that is now programmed into the technologies and we don't have to use it. So you don't see necessarily z-scores used as often anymore. But again, the whole intent is if you have different measurement scales, you want to be able to make comparisons. And let me see if I have the example or have an example. That's not the right one. Gotta find the right lesson, guys. I'm sorry. Typically, by the way, z-scores are rounded to 2 decimal places, and that's a little bit of a carryover from the days when we didn't have technology, because when I didn't have the technology, I would have to do it by hand. And I had to use a table. And the table was set up so that you needed or were required to have 2 decimal places. So let me see if I can work through an example here. This will be a scenario where you might need to use z-scores. It says 3 students were applying to the same graduate school. They came from schools with different grading systems. So you have the student Thad, whose current GPA is 2.4. The school average where he attends school is 3.2, and it gives us the school standard deviation. So all of that information is given, but it looks like maybe that his school uses maybe a 4-point scale. Vicky comes from a school where it looks like maybe they use the traditional 100-point scale, where 90 to 100 is an A, 80 to 89 is a B, and so forth. And then Kamala has a GPA of 8.7. And so they're probably using, there is a 10-point system. It's not used very much, but it's out there. And so we have these 3 students, and I'm trying to decide, we want to decide which one should we admit to the graduate school. But I can't compare them directly because it's different measurement scales. But if I convert them to the standard z-score, then I can make a comparison. So to do that, and I'm going to kind of see if I can sketch it here on this paper, we would use that formula that I just gave to you, and we're basically going to do plugging and chugging together with our handheld calculator to get it. So for Thad, his GPA is the data value of interest. That's my X. This is the average or the mean. And this is the standard deviation. So I would plug and chug into that formula. Z is X minus the mean divided by the standard deviation. So I would have 2.4 minus 3.2 divided by 0.8. Guys, be careful. Make sure you follow order of operations. 2.4 minus 3.2 is negative 0.8. Divided by 0.8 gives me a value of negative 1. That means that Thad's GPA is 1 standard deviation below the average. Because it's negative, that lets me know his average is less than the mean or the average. Not too good. Okay, then let's look at Vicky, and I'm going to see if I can scrunch hers in up here. Okay, Vicky, using the same formula, I would have Z equals 81 minus 75 divided by 20. Okay, so let's see, 81 minus 75 is 6 divided by 20. 6 divided by 20 is 0.30. So Vicky's score is about 3/10 of a standard deviation. It's not even a full unit above average. Hers is above because it's positive. So if I'm just comparing Thad and Vicky, Vicky is better because at least she's above average. Not by much, but she's above average. Then we have Kamala. I'm going to do hers down here at the bottom. So for Kamala, we would have Z equals 8.7 minus 8 divided by 0.4. So I have 7/10 divided by 4/10, which is 0.7 divided by 0.4 is 1.75. So Kamala is 1.75 standard deviations above average. Again, it's above because it's positive, and she's 1 3/4 standard deviations above the mean. So if I'm looking at all three, Kamala and Vicky are definitely better candidates than Thad because they're above average. Between Vicky and Kamala, Kamala is more above average than Vicky because 1.75 is bigger than 0.3. So I would, if I were the admissions counselor, I would admit Kamala to the graduate school because she's the best of the three candidates. But I didn't know that by just looking at their original GPAs because I had 3 different scales. Okay, so that's a Z-score, and that's the primary purpose. And again, we don't use them near as much as we used to, but it is a hand calculation that you have to do. The second measure of position that we use is called a percentile. You have probably heard the word percentiles before, or percentile. If you've ever seen a score report for any kind of standardized test, SAT, ACT, any kind of state administered test, the CRCT, the MAPS testing, end of core test or end of grade test in the state of Georgia, you have percentiles. Because oftentimes on those reports, it'll tell you, you know, your child is in the 87th percentile, or your score was in the 95th percentile. So in thinking about percentiles, percentiles basically divide the entire data set into 100 equally sized groups. Each group contains 1% of the data. Okay, each group contains 1% of the data. There's lots of different ways or methods that can be used to calculate percentiles. A lot of it depends on the assumptions that the researcher plans or is willing to make. So we do not calculate the percentiles. Again, there's going to be computer programs that will do it. Nobody's going to do it by hand, but there are different methods, again, depending upon the assumptions that are made. But the key thing about percentiles is, how do you interpret it? Okay, how would you interpret the percentile? That's the important piece. And I'm going to give it to you in an example. Let's say that you score in the 83rd percentile. What that means is that 83% of all the data values fall below your score. Okay, if you are in the 83rd percentile, that means that 83% of all the data values fall below your score. It's important to realize when you are interpreting a percentile that you are always thinking about it in terms of the percentage below. Even if it said you scored in the 27th percentile, that would mean 27% of all the data values fall below your score. And especially if you are entering maybe the education field, even the nursing or health professions, psychology, sociology, you may very well have to explain percentiles to an individual. Because typically in education, of course, you're going to have, you could have an IQ test, you could have the SAT, ACT, you're going to have the end of grade test, the MAPS testing. And so a parent may not be familiar with or understand that ranking. And so you need to be able to explain it. And I used to have, I don't know what I've done with it, in the field of nursing, especially if you're thinking about pediatrics. I know when my daughter would go to the pediatrician when she was an infant, they would look at the relationship between her length and her head circumference and would make note of the percentile she was in. That determined whether she was developing properly, or was there some sort of issue that maybe needed to be researched. So again, I knew how to read the graphs and the tables that they were providing to me, but there again, if you're going into that field, you may have to explain it to a parent at some point, or a caregiver. So again, the key thing about interpreting a percentile is that it is the percentage below that particular score. Again, you're not going to be asked to calculate percentiles because, again, there are different methods. We're actually going to focus on a subcategory of percentiles, which are called quartiles. Okay, we're going to focus on a subcategory of percentiles called quartiles. Quartiles divide the entire data set into 4 equal groups. And each group is going to contain 25%. Each group contains 25%. So let me go over or scroll down and make some space here and kind of try to draw you a picture. Whoops, hold on. Okay, so if I took my data set and I put it in order so that I have my minimum value, and then I line them up on the number line in order to the maximum. What the quartiles do is the quartiles divide the data set into 4 units. So if we went to the halfway mark, which is our median or our middle value, remember the median we talked about earlier, divides it 50-50, so that I have 50% of the data below the median and 50% above the median. If I divide between the median and the minimum, if I divide that in half, between the minimum and that tick mark, I have 25% of the data, and then I have 25% from the mark to the median. This mark is called quartile 1. The symbol is usually the letter Q with a subscript of 1. Q for quartile with a subscript of 1. And again, it's kind of like, if you want to think about it, it's the 25-75 split, because there's 25% below. It has to total to 100, so that means there's 75% above. If I do the same thing between the median and the maximum and divide it, I have 25%. So I have 4 regions or 4 groups, and each group contains 25%. The tick mark between the median and the maximum is called quartile 3. It's our 75-25 split. There will be 75 below, 3/4, 25, 25, and 25 make 75. So I have 75% below, 25% above. Again, the one in the middle we call the median. It's also could be referred to as quartile 2. Now, most times we're going to call it the median, but it can also be called quartile 2. So the quartiles divide it into 4 groups. We're using quartiles. Again, there are probably different methods, but Minitab will calculate this for us. And so we're going to let Minitab do the work and determine the quartiles. We use the quartiles. Again, one of the reasons we want to use the quartiles is the quartiles are used to determine if outliers exist in the data set. So that's one of the reasons we kind of shift our focus to quartiles. The quartiles are also used on the last graph that we focus on. If you remember, the third graph that we were going to talk about is called a box plot. Okay, we've talked about a histogram. We talked about a stem and leaf. We had not talked about a box plot. And I just about have a box plot drawn here. Typically, the box plot is going to includes your 5-number summary. It displays in a visual way the minimum, quartile 1, the median, quartile 3, and the maximum. Okay, so the box plot is a visual display of the 5-number summary. Again, the 5-number summary is the minimum, quartile 1, the median, quartile 3, and the maximum. We get the idea of a box plot because what we do is we draw a box from quartile 1 through quartile 2 to quartile 3. We draw a box around Q1 to Q3. That area there that the box is around is called the interquartile range, which is abbreviated IQR, and it represents the middle 50% of the data if you're trying to find what's in the middle. Formula-wise, it is Q3 minus Q1. Now, again, Minitab is going to do that calculation for you, but again, it gives you a visual of that 5-number summary. We could also then use that visual, that box plot, to think about where is the box located. If the box is on the lower end or on the left, we say it's skewed to the right. Let me go back up here. I got 5 minutes. Let me go back up here to our graphs. Okay, if you're thinking about the graphs in terms of a box plot, for skewed to the right on a box plot, my box would be on the left-hand side or on the low end. For symmetric, in terms of my box plot, my box would appear to be in the middle. And for skewed left, my box would appear to be on the right-hand side. So I can, again, even use the box plot to determine whether I'm skewed left, skewed right, or symmetric. Now, I'm going to have to stop at that point. I only have 4 minutes left. There's no way that I can show you how to do all those calculations in Minitab and how to interpret them in the next 3 minutes. Okay, so I did not complete the lesson on descriptive statistics. So we will pick that lesson up on Monday, and I'll adjust the due date for that assignment. Please remember that you must take the Module 1 exam by Friday, which is January the 27th of 2023 at 11:59 p.m. You should allot at least an hour and a half. There is no monitoring, but you can use your notes, your PowerPoints, etc. We have omitted class participation 4, but you do need to do class participation number 5. Okay, so we will adjourn for the day. and I will get the recording posted, and I will see you guys on Monday, which will be January the 30th.